All right, today I'm going to show you how to do area of regular polygons. First off, what I would like to do is let's talk about all the regular polygons that we know so far. So the one that has three sides is called what?
Triangle.
What kind of a triangle? Equilateral triangle. What is the regular polygon with four sides? A square. What is the one with five sides called? Pentagon. So I actually want you to draw a nice pentagon. And then those of you watching the video, if you could just, take your time, draw them out, pause the video if you need to, so that you have all of these set up. What's the one with six sides called? Hexagon. What's the one with seven? Heptagon. We're not going to draw it because it's kind of a funky shape. What's the one with eight? Octagon. So it goes like that, and then you drop it down. Okay, so it has 8 congruent sides. Seven was heptagon. What's the one with 10 sides? Decagon. 11 is just 11gon. 12, dodecagon. And anything after that, I don't think we're going to worry about. All right, so what I want you guys to tell me is what is the sum of the angles for an equilateral triangle? Like if I was to add this, this, plus this. What is it? 180. It's not a trick question. How much is it for a square? How much is it for a pentagon? 540. And the way to do that is you can think of like, oh, how many triangles do I have? And here there's 2, and here there was those 3. At some point we used to do it that way. So for each one, you keep adding more. Or remember the formula, n minus 2 times 180? N is the number of sides. How many do we have for an octagon? Or hexagon, I'm sorry. So for this is a pentagon. What's 540 plus 180? What is it? 720. And then plus another 180. That would be the heptagon. Plus another 180. 1080. And if you forgot how to find these, we did learn this formula where you do n minus 2 times 180, which is number of the sides minus 2 times 180 gives you the sum of all of the angles. Now, why am I talking about this? Because we will actually need to know how many degrees is each of the angles in each of the shapes. So for an equilateral triangle, what's that one angle here? 60. That's easy, right? 180 divided by 3.
170, or 720 plus 818, or 180.
But we're missing a heptagon. We're missing a 7-sided, and then there was an octagon. So it's 180 plus another 180. For the square, it's 90. What is it for the pentagon? Take 540 divided by 5. 108. Take 720 divided by 6. It's 120. Take 1080 divided by 8. 135. So that's also going to come in handy when doing area of regular polygons. You need to know the angle. Now, yesterday I told you that the area for any regular polygon is 1/2 A times P. Do you remember what the A stands for? Apothem or apothem, apothem, however you want to say it. What does the P stand for? Perimeter. Now, each of these shapes actually has an apothem. Even though we never learned it for an equilateral triangle, it's just a segment from the center that's perpendicular to the side. And it actually bisects the side that it's perpendicular to. There's one from the square, from the center, perpendicular to the side. Same thing for a pentagon, perpendicular to a side. Hexagon, and then octagon. So all of them are like that. Of course, they could be drawn to any of the sides as long as they're perpendicular, but I'm just used to doing them to the bottom. All right? So here is a very basic example of how would you find the area of a hexagon, a regular hexagon, if I told you that the apothem is 8, apothem, and the side is 10. So that's the very basic, like level 1, almost too easy, because all you have to do is plug it in. 1/2 times 8 times, what's the perimeter? 60. And then multiply this out on your calculator. It is 240, let's say, centimeters squared. So it's very simple if I gave you that type of a problem. But now, let's say you actually don't know what the apothem is. So let's set up another hexagon, slightly bigger this time because I want to explain this. And what if I actually tell you that the side of the hexagon is 12, but you don't know the apothem and you have to find it? What you actually need to create is this triangle right here. Okay? So now there's a couple ways to do it. What I like to think of, well, do we know what this angle in a regular hexagon is? Check up top on the notes. How much did we say this angle was? What is it? No. Just this one angle, not all of them. 120. What's half of it? So that's one way to figure out this angle. Another way, which is actually my preference, because then you don't have to remember all the sums, is this. How many triangles do we have in a hexagon? Like these. 1, 2, 3, 4, 5, 6. What's 360 divided by 6? Come on, guys. 60. So what is each of these right here? 60. Let's see if you notice where I'm going with this. So now if I was to enlarge this one right here, this top angle, I know it's 60. How much? Okay. You're getting confused. Before we were talking about these angles right here. Now I'm trying to find these angles. So how much is it around the circle? 360. So now I'm talking about like these top one. I'm showing you a different way to find it. If you drop the apothem right here, what is this angle here? 30. What is this angle here? 60. I'm showing you a different way of finding this. Because essentially what it comes down to is it creates a 30-60 triangle. So now you just need to memorize. Anytime you have a hexagon, it makes like a little triangle in here that allows you to find the apothem no matter what you have using the 30-60 triangle. So now, if I know this is 12, how much is half of it? 6. So in this sense, we found the short side, and now I can find actually both of these. Which one is the apothem? This one. What's the apothem for this problem? 6√3. If I wanted to, I could find this one, which is 12, but that won't be necessary. So anytime I give you a hexagon, you just need to memorize. It goes with the 30-60 triangle. So now, to find the area, we would do 1/2 times the 6√3 that we have times, what's the perimeter? 72. How did you find that, Firula?
12 times 6.
Right? 12 times 6. Why don't you guys multiply it? Leave it as exact. Only the numbers. 1/2 times 6 times 72. Did you get 216√3?
Yes.
All right, let me show you the third variation of the hexagon problem. So now, like all this work that I was doing here, you don't have to repeat that every single time. You just know that if you draw the apothem like that, you know it makes a 30-60 triangle in there. Okay? And this time around, what I'm actually going to give you is that this segment right here is 16. So I don't even tell you what the side is, and I don't even tell you what the apothem is. You have to find both of those. And the way to do it is to use the 30-60 triangle. So anytime you're doing a hexagon, I'm repeating that for the 5th time, you always use 30-60. Now, which part of the triangle I have? That's the hypotenuse, right? So what is the short side? 8, because we divide by 2. And what's the apothem? Or this side right here, the long side? That's 8√3. Now, in this picture, if I found this to be 8, what's this piece right here? Also 8. So what's the side of the hexagon? 16. To find the area, we would do 1/2 times the apothem, which is 8√3, times the perimeter, which is 96. And then multiply the numbers. So times 8, times 0.5, 384√3. Are we okay with this? Now, there's another way if I only gave you the apothem, and then you would have to divide by √3 to find the short side, double it, and that would give you the side of the hexagon. Okay? So that's hexagon. Let's do pentagons, because that's a little bit different. You will actually have to use SOHCAHTOA for that one. So here's example 2. Draw a slightly bigger pentagon so that you could figure this out. Okay, put the center right there. And this is, again, I'll show you the way to do this so that you don't forget, because into how many triangles now can we split this pentagon? If it has 5 sides, how many triangles are in it? 5. So what I'm trying to find is this angle, this angle, this angle, this angle, and this angle. How do I find that? 360 divided by however many sides you have. What's 360 divided by 5? 72. That means this whole thing is 72, but how much of it do I really need? Because I'm trying to figure out what this triangle with the apothem is going to be. That's what I'm after. 36. So what we end up having for every single pentagon is that this angle is 36 degrees. So what's the other one? 54. So that's one way to do it. The other way to do it was, if you happen to remember that for every regular pentagon, this is 108, then you divide that by 2, and you get this 54. So that's 2 different approaches to finding those angles. Now, let's say I gave you that the apothem for this pentagon is going to be, check, 9. Let's say that this is 9. I want to find this right here. Yuck. How do we find that? Sine, cosine, or tangent? Tangent. So, and it actually depends on which angle you want to go with. Let's go with the 54. So we would do tangent of 54 equals 9/x. Switch the x with the tangent. 9 divided by the tangent of 54. Did you guys get 6.5? Let's round it to the nearest tenth. So if x is equal to 6.5, that's only this piece of it right here. What's the whole side going to be? 13. Now that we have everything that we need, area would be 1/2 times the apothem times the perimeter, which is 65. Multiply it all out, and I got 292.5. So now for a pentagon, this problem, I could do 3 different variations. I could start with giving you the side, and based on that, you would have to divide it by 2, you would have this, and you would still use tangent or sine or cosine to figure out the rest. Sometimes I might give you this one, which is right here. So then you would use either sine or cosine to figure out both the apothem and part of the side. Does that make sense? Let's have you try to figure out what would the triangle be for the octagon. Okay, so draw a big octagon so that you have enough room. Draw the apothem, it's right here. And take a couple minutes now. Let's say we draw this because this is what I'm after. I want you to tell me what is this angle or this angle for the octagon. Take a second to figure it out. Don't forget to split it in 2. All right, did anyone find it? What's this angle? 22.5. How did you do it? 360 divided by 8. That gives you 45 divided by 2. Did anyone use the fact that we actually figured out for an octagon that this is 135 divided by 2? So what's this bottom angle? 67.5. So now it's the same kind of thing. Let's say for this octagon, I told you that this side right here is 12. So it's not even the apothem. It's not the side of the octagon. You need to figure out both of them. So let's make this be 12. That's the A. That's the X. I always put A for the apothem so that I know I'm looking for that. Let's do that one first. Should we use sine? Let's use sine. If I want to use sine, I would do sine of 67.5 equals A over 12. Multiply by 12. So 12 sine of 67.5 is going to be A. What'd you get? 11, or like 11.1 maybe. And now let's do, we could do cosine for x. Cosine of 67.5, and you also could have used this angle, it doesn't matter. It's x over 12. I have 4.6. Yes? So if that is only this half, what would be the whole side of the octagon? If I take 4.6 times 2, 9.2 is the side. The apothem we said we're going to go with 11.1. So to find the area, you would do 1/2 times 11.1 times the perimeter. When you multiply 9.2 times 8, 73.6. Multiply this all out. $408.5?
Yeah.
Yeah? Does this make sense? If I gave you a good example would be, what if I gave you a 10-sided figure? Would you be able to figure this out from scratch? All right, that's a good practice. Note, hint, hint, 10-sided or 12-sided. Yeah.
When you find like the angle,
Mhm.
you just have the triangle, and you do 360 divided by 8. Why do you have to divide it again by 2?
Because when you, that's actually a good question. Because when you do it for, I don't want to mess this one up. When you do it for like an octagon, the first, when you divide it by 8, how many triangles are there? 8. So you're actually finding it for this whole thing right here. But where's the apothem? The apothem goes right down the middle of it. So that's why once you divide 360 by 8, you have to take that number divided by 2. And that works for all of them. All right, so in summary, what I want you guys to do, go back to the top of your notes where we drew all of them. And let's add, next to each of the pictures, let's add the type of triangle that we would use, okay, to find. So because for each of these, you actually have a little triangle in there. What would be that little triangle here for the equilateral triangle? 30, 60, and it would go like that, right? Where would the 30 be? In here. That's the 30. That's going to be the 60.
Wait.
Because this is 60.
Down here. It's for the next
Hmm?
one. Oh, never mind.
Got it? Okay. So then if I was to do this, there's the triangle. Now what kind of a triangle would it be for a square? 45, 45. Right? What is it for a hexagon? And you can just kind of like remember, for a hexagon it's always the 30, 60.
So it has hexagon or pentagon?
Oh shoot, pentagon. Good call. That's for a hexagon. Good call, good call. Thanks, Daniel. That's for the hexagon. What is it for a pentagon? So this one is 54. What's the top one? 36. For a pentagon, 36, 54. Thank you. So 30, 60 for hexagon. An octagon, we just figured it out. That's the 22.5 and 67.5. Now, of course, if at any point on the test you forget what triangles to use, you can always just easily figure them out. All right.